Bismillahirrahmanirrahim. Uh, so here is a problem. The random variables x and y have the joint PDF given below. Fx comma y is equal to 5 over 2x square, where x lies between minus 1 and 1, and y is greater than or equal to 0 and less than or equal to x square, and this is 0 otherwise. So let A be an event such that y is less than or equal to 1 over 4. So find the following. The conditional PDF of fx comma y given A x comma y, and the conditional PDF of y given A and expected value of y given A, and the conditional PDF of x given A and expected value of x given A. So before we begin to solve this problem, we need to plot this region of non-zero probability. So let us plot it. This is x-axis we have, and y, and x ranges from minus 1 to 1, right? So x is say minus 1 here, and this is plus 1 here. So this line defines x is equal to minus 1. So this line defines x is equal to plus 1. So it is within this region. This is defined by this expression, x greater than or equal to minus 1 and less than or equal to 1. And the second, we have y is greater than or equal to 0, which means it is positive always, and y is less than or equal to x square. So x square, if you plot it, is like, it's like this, right? Right. So this is y is equal to x square, and y less than x square means it is this region, right? So this is this region, y is equal to x square, and because x is minus 1 here, so if you put x minus 1 here, so this will come out to be y is equal to 1. So this is y is equal to 1, and x and y is 0 here, right? So this is y is equal to 1, and here also if you put x is equal to 1 here, so y is 1 here also, right? So it is this region here defined by these functions. So now we are interested in the event A. So event A says that y is less than or equal to 1 over 4. So if y is 1 here, so it is say 1 over 4 here. So it means that y is 1 over 4 is this region, which is below this, right? So it is this region which is the event A. This entire region is event A. So as y is 1 over 4 here, right? So what will be x over here? So x is equal to this is y square root here, and x is equal to, on this slide, x is equal to minus y square root here. So this is minus 1 over 2, and likewise this line here is, this is x is plus 1 over 2 here, right? And y is 1 over 4 here. So now it is this region that we need to find out to determine the conditional probability of x comma y given A x comma y. So as you know, the conditional probability of x comma y given A x comma y is given by this expression, f x comma y divided by the probability of A, right? And x comma y is bounded by this region A here, should be bounded by this region here, and this is 0 otherwise. So we already have this joint PDF with us. We need to find out the probability of event A to determine this conditional joint PDF. So the event A, as I said, is this region. So we need to integrate over this region. So probability of event A is given by this double integral evaluated over this area A, right? And we need to integrate this joint PDF over this region, right? So there are two ways, as always, to integrate over this region. We can assume a vertical strip here, right? And then start moving from left side to rightmost side. So if you see that if we assume a vertical strip till here, no, this is the bound, upper bound for y is equal to 1 over 4, right? We need to below this region, remain below this region, and y will be from 0 to 1 over 4 here. But here, from here onwards, the value of y changes. So what we'll have to do is we have to evaluate two integrals over this area, right? And furthermore, another two integrals over this area. A total of 4 integrals if we assume a vertical strip. But if we assume a horizontal strip like this, or here for example like this, then we just need to integrate from this point here to this point, only one integral per area. And as this side is symmetrical to this side, we can just calculate one integral and then multiply it with 2 to evaluate the integral over the entire region, right? So for example, let's assume this region, and let's assume this strip here. So probability of event A is given by this integral, and this is the PDF here. We have 5 over 2 x square and dx dy. X is this, these are the limits for x and these are the limits for y. So now let's determine the limits for x and let's determine the limits for y. You see, x varies from this point till this point. At this point it is bounded by this curve. So x is equal to y square root here. So x is equal to y square root, and at this point x is equal to 1, right? And y, it remains below 1 over 4 from 0 to 1 over 4. So y ranges from 0 to 1 over 4. So these are the limits for y, 1 over 4, right? So it is this integral that we need to evaluate to find the probability of event A. Oh, sorry, we need to multiply this with 2 also, because we are evaluating only this area right now, this region here, right? And by symmetry, this area is also similar. So we, instead of evaluating this integral again, we just multiplied it with 2, right? So let us start integrating first with respect to x and then with respect to y. So probability of event A is given by 2 y is equal to 0 to 1 over 4 here, right? And this is 5 over 2 x cube over 3, and the limits vary from y square root to 1, and we still need to integrate with respect to dy, right? So again, probability of A is given by, let's take this out. So 2 multiplied by 5 over 2 multiplied by this 1 over 3, right? And y is from 0 to 1 over 4, and x cube, let's put these values now. So this will be 1 minus, this is square root y 1 over 2, so this will be y raised to the power 3 over 2 here, right? 3 over 2. And we still need to integrate with respect to y. This is 3 over 2 here. So So probability of event A is now given by, this is 5 over 3 and y is equal to 0 to 1 over 4, and this is 1 minus y raised to the power 3 over 2 and dy. So probability of event A is given by 5 over 3, and this is y, and minus 3 over 2 plus 1. This should be 5 over 2. So 2 over 5 multiplied by 5 over 2, and this is 0 to 1 over 4. So probability of event A is given by 5 over 3 y, the value of y is 1 over 4 here, 1 over 4 minus 2 over 5 into 1 over 4 raised to the power 5 over 2, right? So probability of event A is given by 5 over 3 into 1 over 4 minus 2 over 5, right? This is 1 over 2 is a square root, so this becomes 1 over 2 and raised to the power 5. So probability of event A is 5 over 3, 1 over 4 minus 2 over 5 into 2 raised to the power 5 is 32, right? So 1 over 32, and this should be 2 into 1, 2 and 16, right? So probability of event A becomes 5 over 3 into 1 over 4 minus 1 over 80. 16 into 5 is 80, right? So let us carry it forward. So let me repeat that expression here for convenience. So probability of event A is equal to 5 over 3, 1 over 4 minus 1 over 80, right? So probability of event A is 5 over 3, this LCM is 80, this is 20, this is minus 1. So probability of event A is 5 over 3, and this comes out to be 19 over 80, right? So we can simplify this. 5 into 1, 5, and this is 16, right? So probability of event A is 19 over 16 into 3, 48. So here we have the probability of event A. So we can now put it, this value, in this formula here that we earlier written down to find out the conditional probability of xy given A. So right, so let's substitute this. So fx comma y given A, x comma y is equal to, so fxy, the PDF is 5 over 2 x square, and we need to divide this by this. So this is 48 over 19 multiplied by 48 over 19. So this comes out to be, this is 24, right? So x comma y is equal to 5 into 4 20, and 5 into 2 10 and 12, 120 over 19 x square. So this is the simple expression. Formally it can be written down like this. (120 over 19 x square). And what are the constraints for this? All those constraints that were used to calculate this, these constraints remain there. The added one is this one is also added here then. So x is greater than or equal to -1, less than or equal to 1, y is greater than or equal to 0, less than or equal to x square, and y is less than or equal to 1 over 4, and this is 0 otherwise. So this is the complete expression of the PDF, the conditional PDF of xy given a. So we are done with the first part of the problem. Now let's begin with the second part. So this is the marginal PDF. Fy given a is, as you already know, this is given by integrating out the random variable x out of the joint PDF, conditional PDF that we have here now. So minus infinity to plus infinity here, right? And fx comma y given a, right? And x comma y dx. So I need to integrate out from this region. This is the conditional PDF here, it is over this region. We need to integrate over the entire x region here, right? So x region, this can be divided into two parts, symmetrical parts, one from -1 to 0 and other from 0 to 1, right? So we can integrate only over one region and then multiply it with 2 to actually arrive at our result. So fy given a of y is given by this integral, the conditional PDF here, right? So 120 over 19 x square, and we are integrating with respect to x, right? And the limits for y, again we have to look at this region. So if we need to determine the limits for x, we need to look that if we move this, if we look at this strip, so x is square root y here and x is 1 here. So from here to here, x is under root y to 1. So this is square root y to 1 here. So fy given a y is, let's take out 120 over 19 outside, and this will be x cube over 3. Let it write down 1 over 3 here, and this remains x cube, and this, the limits are square root y to 1 here. So fy given a is 3 to 4, 40 over 19, and x cube into 1 is 1 minus y, this is y 1 over 2. So this will be basically y raised to the power 3 over 2 here, 3 over 2. So this is the PDF for one region only. We needed to multiply it with 2 actually to get the PDF of the entire region. So this needs to be multiplied by 2 here, this needs to be multiplied by 2 here. So this will be 80 over 19. So fy given a y is equal to, it can be formally written down like this: 80 over 19, 1 minus y raised to the power 3 over 2, right? And the support for this is y is equal to 0 to 1 over 4 here, right? So y is greater than or equal to 0, less than or equal to 1 over 4, and this is 0 otherwise. So right, so this is the conditional PDF for random variable y. Right, so this completes our second part. we need to do now find out the expected value of y given a. So this was our part B. Now let's begin with part C, expected value of y given a. So this can be calculated directly from this PDF here. So expected value of y given a is given by this integral from minus infinity to plus infinity, y multiplied by this conditional PDF of y, fy given a, y, and we integrate with respect to dy here, right? So expected value of y given a is y multiplied by 80 over 90, 1 minus y raised to the power 3 over 2, right? And we still need to find the limits, and we are integrating with respect to y here. So we see that the limits for y are from 0 to 1 over 4 here, 0 to 1 over 4. So expected value of y given a is given by, let's take this constant outside, 80 over 19, and 0 to limits are 0 to 1 over 4. Y multiplied by 1 is y minus y raised to the power 3 over 2 plus 1 is 5 over 2, and dy, right? So expected value of y given a is let's keep this constant here, 80 over 19. So this will be, when integrated, y square over 2, y square over 2, and minus 5 over 2 plus 1 will be 7 over 2. So this will be 2 over 7 here multiplied by y raised to the power 7 over 2, right? And our limits will be from 0 to 1 over 4, right? So expected value of y given a is 80 over 19. We put 1 over 4 here. So this will be 1 over 4 squared 1 over 16 and multiplied by 2 in the denominator. This will be 1 over 32. So minus 2 over 7 and 1 over 4 raised to the power 7 over 2. So expected value of y given a is equal to 80 over 19. So this is 1 over 32 minus 2 over 7. So this 2 in the denominator is basically the square root for this. So this will be 1 over 2 raised to the power 7, right? So expected value of y given a is equal to 80 over 19, and this is 1 over 32 minus 2 in the numerator and 2 raised to the power 7 in the denominator. So this will be 1 over 7 multiplied by 1 over 2 raised to the power 6. So expected value of y given a is equal to 80 over 19 or 1 over 32 minus 1 over 7 into 2 raised to the power 6 is 1 over, this should be 1 over 64, right? 2 to the power 6 is 64. So expected value of y given a, these are merely now calculations, simple calculations. 1 over 32 minus 1 over 7 into 4 28, 7 over 6 42, and 2 4 4 8, right? So I think we should get to the calculator here, so to make it easier for us. Just a minute please. So 1 divided by 32 minus 1 divided by 448 and multiplied by 18 divided by 19, this comes out to be 65 over 532. So this is the expected value of y given a. So this was our part C that we have evaluated here now. So our next part is to find out the conditional PDF for random variable x given a, right? So let's begin that. Part D, f x given a of x, right? So now we need to integrate out the random variable y from this region to obtain the conditional PDF for random variable x. Like we did integrate out random variable, here, random variable x here. So this will be minus infinity to plus infinity f x comma y given a x comma y, and we need to integrate with respect to y now. So fx given a of x is equal to, let's look at the region that we are integrating here to get the conditional PDF of random variable x. And note that we are now integrating with respect to variable y. So we will be moving in this direction, right? So as we discussed earlier, if we look at this region on the left side of the y-axis, this can be divided into two parts. So variation of y is, till here from -1 to -1 over 2 is from 0 to 1 over 4, right? But from -1 over 2 onwards till this region here 1 over 2, y is equal to 0 here, and here it is y is equal to x square. Y is equal to 0 to x square here within -1 over 2 to 1 over 2. Again from 1 over 2 to 1, the variation of y is from 0 to 1 over 4. So these are three regions in which we are interested. Two of these regions are similar, -1 to -1 over 2 and from 1 over 2 to 1, and between these regions again we can find out the value of the conditional PDF here, right? So we can divide this region into basically three parts. But as I said, these two parts are similar, and these two parts are also similar, and actually the variation of y does not change from here to here. So this will be one integral to calculate here, and this will be one integral to calculate here, and we can use this value here for this region also. So let us just integrate for this region first. Y is equal to 0 to x square here when x is from -1 over 2 to +1 over 2. So we need to put the value of the conditional PDF of here, 1 over 20 over 19 x square, right? And we are integrating with respect to dy, and the limits for y are from 0 to x square here, right? And we are integrating for this region from -x when x is equal to -1 over 2 to +1 over 2. So y is equal to 0 to x square here, right? So fx given a of x is equal to, let's take this constant outside, 1 over 20 over 19, and this is 0 to x square, so x square dy. Basically we are integrating with respect to dy, so x is also can be treated as similar to the constant, right? So let's move it forward. So f x given a x is equal to 1 over 20 over 19 x square, and we have y with limit 0 to x square. So fx given a of x is equal to 1 over 20 over 19. This is x square, and this is x square minus 0, so this is again x square. So fx given a, x is 120 over 19, so this will be x raised to the power 4. And this is when x is from x is from minus 1 over 2 to plus 1 over 2 to plus 1 over 2, right? So it's one part only. For the second part, we just need to evaluate this region here, and we can use this value for this region also, right? So in this region, y will be from 0 to 1 over 4, right? We just need to evaluate the same integral but with different limits now. So for the next part, so fx given a of x is equal to minus infinity to plus infinity fx comma y given a x comma y, and we are integrating out the random variable y here, right? So fx given a of x is equal to the limits of x as y are, as I told, is 0 to 1 over 4. So these are 0 to 1 over 4, and the PDF we have, conditional PDF we have, is 1 over 20 over 19 x square and dy. So fx given a, x is, we take this constant outside, 1 over 20 over 19, right? And we can write it here, and y limit is from 0 to 1 over 4. So fx given a of x is equal to 120 over 19, right? So x square, and the limit changes from 1 over 4 to 0, it will be 1 over 4. So this will be 30. So fx given a of x is equal to 30 over 19 x square. So this is now for the region when x is, actually this is for the two regions. We calculated this value for here, but this is also applicable here. So the PDF, the conditional PDF of x is 30 over 19 over x, into x square when x is plus over 1 over 2 to 1, and also when x ranges from minus 1 to minus 1 over 2. So we can write the interval for it here. So when x is greater than or equal to minus 1 and less than or equal to minus 1 over 2, and x is greater than or equal to 1 over 2 and less than or equal to 1. So it is one part of the PDF, actually two parts, one for this and one for this, and the second part was calculated here. So we can combine them together, right? So the conditional PDF of x given a is given by, we need to write it down for the three regions. When x is equal to minus 1 to minus 1 over 2. So this is 30 over 19 x square, and value of x is here is x is greater than or equal to minus 1 to less than or equal to minus 1 over 2. And then within this region from minus 1 to plus 1 over 2, it is this value 120 over 19 x raised to the power 4, and x is from minus 1 over 2 to less than or equal to plus 1 over 2, right? And the third region again, here this one, so it is again 30 over 19 x square, right? And x is greater than or equal to 1 over 2 and less than or equal to 1, and this is 0 otherwise. So this is the PDF that we have, conditional PDF of random variable x that we have. So this is our part D that we have calculated. Now we are left with the last part, expected value of x given a. So part E, expected value of x given a. So expected value of x given a is given by this integral from minus infinity to plus infinity. So we need to multiply x with this conditional PDF of x, fx given a x, and right, and we need to integrate with respect to x here, right? So expected value of x given a is given by we write down the limits. We need to integrate for all these three regions, right? For this this integral will translate into the summation of three further three integrals. So for this region we need to multiply x here with this. This will be 30 over 19 x square, so minus 1, 2 minus 1 over 2, right, and dx, plus then this region minus 1 over 2, 2 plus 1 over 2. So we need to multiply x with here. So this will be 120 over 19 x raised to the power 5, right, and dx, and plus this region here 1 over 2 to 1, so 30 over 19, so x cube dx. So these are three integrals that we need to evaluate to find the expected value of x given a, right? So let's evaluate each integral. X given a is equal to, let's take this constant outside, so this is 30 over 19, right, and this will be 1 over x cube over 3, so 1 over 3, right, and 1 over 3, and this will be, limits will be this will be x cube, and limits will be from minus 1 to minus 1 over 2, right, and then plus the next integral 120 over 19, this will be x 6 over 6, this is 1 over 6, and this is x raised to power 6 from minus 1 over 2 to plus 1 over 2, right, and the last integral will be this one. So this is 30 over 19, right, so this is this must have been 30 over 19 x square here, so multiplied by x, this should be x cube here, right, and after integration this should be 30 over 19, and this should be 1 over 4 here, right, 1 over 4, and this will be x raised to the power 4, right. So this is actually 30 over 19 x square, and we need to multiply it with x, so this is 30 over 19 x cube, right, and this comes out to be 30 over 19 x raised to the power 4 over 4 when integrated, right, and this one here, this was 120 over 19 x raised to the power 4 here, right, and with when we multiplied with x, this comes out to be 1 over 20 over 19 x raised to the power 5. Okay, so this integral also here 30 over 19, 1 over 4, and this is x raised to the power 4, and the limit is from 1 over 2 to 1 here. So expected value of x given a is given by, so this will be 2 into 2 4 into 15, so 15 over 38, right? So 15 over 38 and minus 1 over 2 raised to the power 4 and minus 1 raised to the power 4, right? So, and next this will be 6 into 2 0, this will be 20 over 19, and x raised to power 6, we need to put 1 over 2 here, so 1 over 2 raised to the power 6 and minus 1 over 2 raised to the power 6, right, plus the same here, this is 2 into 2 4, 2 into 15 30, so 15 over 38 and this is 1 raised to the power 4, this is so this remains 1 and minus 1 over 2 raised to the power 4 here, right? So let's look at this. So expected value of x given a is equal to, so 15 over 38, 15 over 38 here, so we need we can take this common, so 15 over 38, this comes out to be minus 1 over 2 raised to the power 4 is the same as 1 over 2 raised to the power 4, so 1 over 2 raised to the power 4 minus this is minus 1 raised to the power 4, this is basically 1 here then, right? And this was minus 1, this is plus 1 here, and this is minus 1 over 2 raised to the power 4, right? This is minus 1 over 2 raised to the power 4, and then we have this expression 20 over 19, this is 1 over 2 raised to the power 6 minus 1 is 1 over 2 raised to the power 6, so this is again basically 1 over 2 raised to the power 6. So as you see, this cancels out here, this cancels out here, this cancels out here, this cancels out here, leaving the entire expression to be equal to 0. The expected value of x given a is 0. So this concludes our solution to this problem.